Let's go. Chapter 15, blood. Now we're getting into the good stuff. We're going to describe the three functions of blood. Okay, its composition. Okay, we're going to use words like erythrocyte, leukocyte, thrombocyte. Okay, we're going to explain the formation of blood, erythropoiesis. And would you believe that blood formation, the need for new blood, again, is controlled by the kidneys? All right. We're going to explain the composition, characteristic, and function of red and white blood cells, platelets, including the breakdown of red blood cells and this kind of stuff. Sorry, I thought my dog was out. What does blood do? Transport. It moves things from one place to another. Oxygen, carbon dioxide, nutrients, waste. Regulation. Temperature. Interesting. Acid base. Okay. Fluid, electrolytes. These kinds of things. All right. They're all have to do with the blood. And also in protection, which we saw there last week there when we were learning about first line of defense and second line of defense and all these ones here. Okay, so transportation, regulation, and protection. Good. So let's have a look here. What is blood? So, see, we've got white blood cells. Okay, we've got RBCs. We've got platelets. Okay, we've got all these different things going on. So blood is not just one thing. Blood is a whole bunch of different things. All right. The cells, cell fragments, dissolved nutrients, oxygen, waste, hormones. It's just a complete cocktail of stuff. Okay. It is a liquid, which is 3 times more viscous, thicker than water. RBCs, white BCs, cellular fragments, platelets. All right, lots going on here. There's two main parts to the blood there that I want you guys to see. There's the whole blood, and then we have plasma. And I think I have a shot of this right here, where if we take a sample of blood, and this is what they do, right? They take your sample of blood and they put it in what's called a centrifuge. It's a machine that's basically, I don't really have anything around here that orchestrates this, but you know, you take a lasso, you know, like a cowboy, and you throw your rope and you catch your horse or whatever. This whole idea of spinning, okay, it pulls things to the outside. It's called centripetal force. Okay, it pulls things to the outside, and so what they do is they'll put a vial of your blood or somebody's blood into what's called a centrifuge, and it's this little machine like this, and what it does is it's like a midway ride, and it just spins this blood around in a circle, and I mean like 100 times in a second. Like, it's just monstrous, and the amount of pressure that's under this blood. And what happens is we can separate this blood. And generally, about 55% by mass, by volume here, is your plasma. Now, what is plasma? Okay, it's just this clear yellowish fluid. Okay, that does have a whole bunch of things in it that we'll talk about. You've got the RBCs, your erythrocytes. I love that word, erythrocytes. They make about 45% of the blood there by volume. Okay, you got your erythrocytes, RBCs, leukocytes, white blood cells, which we've kind of talked about. You remember your T cells, your B cells involved in infection fighting? Okay, and then you got thrombocytes. So erythrocytes, leukocytes, thrombocytes. These are your platelets. Okay. The 2 parts of the blood here are illustrated, and the 2 phases appear. I just want you guys to have a... Don't forget about this little buffy coat layer. This is a thin layer of cells between the plasma and the RBCs. These are your WBCs, and these are your platelets in here. These are your white blood cells and your platelets in here. So plasma, this is just, you know, the ooze, the yellowish ooze there that you'll sometimes see if you leave a cut there for too long. Okay. I want to go back into here. Go back to here. So your plasma, it's mainly composed of water, electrolytes, ions, waste, plasma proteins, albumin, clotting factors. Okay, fibrinogen. You remember that there? Remember the fibrinogen cells there? That whenever you have a cut, it's sticky, it's matte, it sticks all together. So therefore now you have the ability there to form a scab over your cut, right? You've got the serum there. And we'll get into more of the plasma there later on when we get into type AB, and O blood types and what goes on there. Albumin, main protein involved in maintaining blood osmolarity. 55% of blood proteins there. You've got globulins. They have a variety of functions, including enzyme, immune function, immunoglobulins, and we're going to get into antibodies there later. Okay, remember an antigen and an antibody. We'll get there. There's your fibrinogen, clotting factors, lipoproteins, low density and high density fats. Okay, good. Origin of blood cells, process of blood cell production, 2 locations of Hemopoiesis. Love that word too. Okay. There's myeloid hemopoiesis and lymphoid hemopoiesis. Myeloid and by the way, hemopoiesis, this is the process of making blood. Heme, iron. Okay. So myeloid hemopoiesis occurs in the red bone marrow. Lymphoid happens in the lymph tissue. Okay? And you guys can have a look here. Myeloid hemopoiesis there produces red blood cells, white blood cells, platelets. Lymphoid tissue produces only lymphocytes, WBCs. Okay, white blood cells. I have this here because I want to, there's a whole bunch on here that I didn't want you guys to forget. So yeah, it looks like a mess here, but I didn't want you guys to forget this, okay? Because this is all good stuff here. So you have a look. The hemopoiesis in the red bone marrow. So you have a look. So stem cells, they start off all, okay? And this is where the science tends to be going. We can start off with stem cells and we can create all these different other kinds of cells. So from the same stem cell, we can make RBCs. Okay? Have a look at your white blood cells. Okay? I'm not really interested in any of these. If you can understand there that stem cells can make, the same stem cell can make all of these guys, that's what I'm interested in, okay? These are all your white blood cells. Okay, you've got neutrophil, eosinophil, basophil, okay? Lymphocytes here, monocytes, and then over here are your platelets. So this is what we're looking for there. And so I took this out of here and put it up here. What happens if the stem cell commits to 1? Well, there's your 1, right? It's right here. And it'll become an RBC. What happens if it commits there to 2, 3, or 4? It'll become a WBC, a white blood cell. And I wanted you guys there to know that a platelet is not really a true blood cell because it's only a fragment. Okay? If a stem cell commits there to column 5 over here, okay, it becomes a megakaryocyte and then a platelet. And just by the way, you should know that RBCs, they don't have a nucleus, they don't have any DNA, and after about 3 months, they get the chomp. Okay? which we'll get into there, the degradation of blood. Hemopoiesis there on the red bone marrow. Okay. And you guys can have a look at this. It's kind of the same slide there. And just want you guys to know that one stem cell, depending upon the need, can go here, here, or here, and make all of these. This is where science is going right now. These stem cells are pretty impressive, and that's been the whole problem, like with a paralysis victim, is we can't regrow nerve cells. Well, maybe we can. There is some ethics involved. We'll leave that for you to decide or another day. Shall we? Bone marrow depression there occurs if the bone marrow cannot produce enough blood cells. Okay? And the results there, RBC deficiency. Okay? And again, I'm not really into diseases as of yet. I would rather you guys know more about the body than what attacks it at this point in time. So naming any type of diseases, at this point in time, I can say that don't really worry about it. But, yeah, there might be something from these here. Bone marrow overactivity leads to excess RBC production. Okay? Polycythemia. Okay? Too much blood there can burden the heart, overwhelm the clotting system, and can actually cause some type of physiological features there on a macro stage there in the face there. You can get a red face or palms, the hands there, okay? I put this slide in here just to show you all the different components of the blood. And we'll just go through it. You see, you've got your same 45% RBC and then your 55% your plasma, right? So, and you'll see what goes on here. The plasma, electrolytes, water, proteins, waste, nutrients, vitamins, hormones, gases, it's all in here, right? And these are your main gases. There is nitrogen, always, because you're breathing in air. But nitrogen is pretty inert gas, except when you go diving underwater. It can cause big trouble. I don't know if you guys have ever heard of symptoms there of the bends, B-E-N-D-S. When you come up from underneath the water too fast, this nitrogen will actually, it's dissolved in the blood under pressure, but if you come up too fast, it'll turn into a gas. Oh, it's a bad one. Proteins that are dissolved in the plasma, we've talked about albumins, we've talked about globulins, there's even fibrinogen as well, okay? Platelets, RBCs, and white blood cells. And you have a look here, okay? Neutrophils, eosinophils, basophils, monocytes, and lymphocytes. These are all your WBCs. And you'll see here, your red blood cells, they're disc-shaped. Okay, they're kind of flexible. All right? You see they've got these kind of depressions there in the middle. Because the RBCs can bend, it can squeeze its way through tiny blood vessels. Okay? Flexibility allows the RBC to deliver oxygen to every cell in the body. Contains hemoglobin. Okay, good stuff. And you got, what is the function of hemoglobin? Carry oxygen. Why blood changes color? Oxygenated blood that has oxygen, we actually call it oxyhemoglobin. Okay? And bright red. Okay? And lack of O2 makes the blood kind of a bluish red. And you'll see there that arteries don't hang out close to the skin surface. All right? Because it's oxygenated blood, we got to protect it, so they tend to be deeper into the skin. All right? But you'll see there that veins can hang out closer to the skin. And you'll see there that there's a bit of a bluish color because they're carrying blood that is low in oxygen and high in carbon dioxide. Okay, so that's why they have a little bit of a bluish. Cyanosis is a sign of hypoxemia. Blue lips. You know, when you don't have enough oxygen there, your lips will go blue. Okay. Substances essential for hemoglobin production: healthy bone marrow, lots of iron, vitamin B12, folic acid. You'll know that one. That one there, folic acid for pregnant females there. That's a gimme. Okay. Please consult your doctor. Healthy kidneys, erythropoietin. Okay. Absence of bleeding and hemolysis there. The production of healthy red blood cells requires many substance conditions, okay? Deficiency of other raw materials, they can cause trouble like you wouldn't believe. Missing one thing here. You'll have a look here. If there's low oxygen levels in the blood, the kidneys secrete erythropoietin. Told you there, the kidneys are the big boss, and they really are. And it's crazy how these two little organs there, they're not very big at all, like, you know, and they command so much respect. And the kidneys there, when there's low oxygen there in the blood, they secrete erythropoietin, which stimulates the bone marrow to produce more RBCs. The bone marrow, you got it inside the bones, generally the flat bones, and the long bones like the tibia and the femur. Okay, and you see low oxygen, kidneys produce erythropoietin, bone marrow. There we go. Easy peasy. Removal and breakdown of red blood cells. Okay, normal RBCs there, they're about 120 days, so anywhere from 3 to 4 months, and then they get the chomp. Okay, but nothing is wasted. Everything is utilized as best as it possibly can be. Okay, so an old RBCs, they're dismantled, but everything there is kept. Do I have a video? Hemoglobin breakdown. Yes. Internet.
When old red blood cells rupture, the release...
Screw it. Good enough. I'll post those videos there and you guys can watch them. How's that sound? Instead of just sitting around here waiting for my internet. So you guys can see there that the whole process, the iron is extracted, the hemes are extracted, all the protein there from the globulins is transformed, is broken down back into amino acids so that we can use those amino acids again. And all the bile pigments there changed into what's called bilirubin. And this stuff is flushed away, and it's why our feces looks brown, because most of it there is from recycled and getting rid of changing the RBCs. Okay, so you guys can have a look at this. Okay, there's even a really good little video on there about, where is it? Blood and hemolysis and crenation. Please make sure that you watch all these videos, because just the whole idea, what happens when you put blood into water? What happens if you put blood into salt water? Okay, these whole things. And yeah, have a look at these videos. I promise I'll post this right after. Okay. Jaundice, this is a yellowing. Okay. And the yellowing of the skin. Okay, there's a problem here. We'll call them hemolytic jaundice. It's a rapid breakdown of RBCs. Okay, you get too much bilirubin producing, and what happens is you get this backup. You get this yellowing of the skin, yellowing of the eyes. Okay, you know that there's a problem here. Okay, so have a look at jaundice. Anemia. And I don't know if you guys have heard of sickle cell anemia. You know what I mean? These this is a disease where these are your normal RBCs, right? And they work fine. But in some places of the world, you get these RBCs that kind of look like half moons, like a crescent moon. And you think, what's going on here? Because people who have sickle cell anemia, their ability to transport oxygen to the cells is limited now because you're dealing with an RBC that looks like a crescent moon. But it's an evolutionary defense against malaria. And it's amazing how things can work, and it may look like a disadvantage, but really it's an advantage. So, but anemia is there's insufficient red blood cells. RBC production falters if conditions are disordered or necessary. You've got sickle cell anemia, hemolytic anemia, and hemorrhagic anemia. Have a look at those ones there, okay? The white blood cells, we'll zoom in. I'll have a look here. See, there's your blood vessel there. Your white blood cells, funny enough, they have the ability to jump ship. If there's a problem going on over here, they can actually squeeze through. Some of them can actually squeeze through the lining of the artery and get to where it needs to go. Okay? And everything gets the chomp. So let's have a look here. White blood cells there, they protect the body against infection and inflammation. We kind of saw these a bit there last week. Phagocytes there, there's neutrophils, monocytes. Okay, there's ionophils, there's basophils. Okay, and they can leave the blood. They can jump ship and they can travel right through. It's quite amazing, actually. Have a read down here. White blood cells function primarily to protect the body by destroying disease-producing microorganisms, pathogens, and removing dead tissue. Okay? Leukocytosis is excess WBCs, a response to infection and inflammation. Leukopenia is a deficiency of WBCs. It's usually caused by myelin suppression there. And again, I'm not really interested in diseases. I'm more interested in the body itself. Okay? Classification of white blood cells there. You've got granulocytes, neutrophils, basophils, eosinophiles. I don't know why I'm having difficulty saying that there today. Have a little bit more Coke. And then we've got lymphocytes and monocytes. So have a read of these. Be able to tell what each one does, generally speaking. The neutrophils there, these are the most common. Okay. Most important role, chomp, chomp. Phagocytosis, chomp, chomp. Okay. Cells quickly move to the site of infection where they remove the tissue there that needs to be removed. Okay. You guys can have a read of these basophils, eosinophils. I don't know why I'm having difficulty saying that there today, but you guys can have a read of these there. The basophils are present in small numbers and play a role in the inflammatory process. I think I have a video of that as well. Okay, so please have a look at that one. These guys here, they eosinophils, they secrete chemicals that destroy certain parasites. Okay, they also do the chomp chomp. So you guys can have a read of these there, and this is a slide there that the publisher made there. You guys don't have to remember these, but this is a nice little slide there. It's a little anagram to remember all the different ones, as you like. The platelets, tiny little structures, fragments. They're produced in the red bone marrow. Okay. Thank you, Harley. Hey, Harley. All right. My dog saw a squirrel. So these platelets that are produced in the bone marrow, they only last about 5 to 9 days. Function, prevent blood loss. Key role in hemostasis. So why is a platelet called a thrombocyte? The platelet helps in the formation of blood clots. Thrombus. Okay? And what's that called there? Thrombosis. Just the whole idea of when you're on a long haul airplane, like if you're flying from here to Australia where it's a 16-hour flight, they tell you to get up every couple of hours and walk around and get the blood moving, because if you're staying there, if you're sitting down for too long, there's a possibility there of thrombosis happening where you can get a blood clot in your leg. So that's that one there. Blood counts, just to let you know that at any given point in time, we have anywhere between 5 to 6 liters of blood in us only. That's it. About 5 liters. That's all we got. Okay. Complete blood count there provides an information about blood composite. So what they can do, they take a sample of your blood and they just count the number of RBCs that are in the slide there under the microscope, and they make a projection about how much blood you have, these kinds of things. So we can count the blood. You can even count the RBCs or the WBCs as well. Okay. The next part here, we're going to talk about hemostasis, blood types, and RH factor. Okay. RH factor there, we're dealing with moms and the unborn child. And anyone there who's had a child, guaranteed that you were tested there, especially your first child there, you're tested there for your RH factor. Okay? Which we'll get into that. Hemostasis, prevention of blood loss. So, there are 3 things that happen. Okay? I'm just going to... Everyone okay? Everyone okay? I'm just going to stop sharing for a second. Everyone okay? You guys can hear me? Everything's good? All right. Let's go back. That's what I need to know. I don't want to get rambling. And I totally apologize. There was a video there. I think it was last week or the week before. I don't know what happened, but the video didn't work. But the audio, and I don't know. I totally apologize for that. I don't really understand what went on during that. But hopefully everything appears to be all right, and we have good video there this week. Please note for this one here, hemostasis, there are 3 points. There's what we call the vascular spasm. There's another one there called a platelet plug. And then there is coagulation. Now, like let's say you have a blood, an artery or something like this, right? And it gets cut. What'll happen is this end of the artery and this end of the artery, they used to be joined, right? But then they got cut. So now we have these 2 ends. What happens is there's this spasm, this recoil. Good sound effects. And this is very, very important because what happens is it kind of puts pressure on these 2 ends. So therefore, now that they're kind of closed but not really, like there's damage here, right? You've just cut an artery, but there's this spasm that happens that stops blood from leaking into everywhere where it shouldn't for a little bit of time. It gives the body, I don't know, I want to say 5 seconds or 10 seconds before things really start to happen, and it gives the body time to get all the people there that need to get there. Okay, so we'll go into more detail right here. Aspirin. You know that they say there when you feel like you're having a heart attack, you take a little bit of aspirin. I think it's aspirin 88. It's a special kind of aspirin. It's a low-dose aspirin. When you're having a heart attack or you feel like you're having a heart attack, take an aspirin, and what happens is it dilutes the blood. Okay? It makes the blood thinner, more waterier, so that if you have a heart blockage, at least if you take an aspirin now, you've got some watery blood. Hopefully we can get some blood through that blockage enough to get the cells on the other side of the blockage some oxygen so we can get you to the hospital to keep you alive. That's what this is, right? So The aspirin is a blood thinner, okay, that temporarily keeps the blood thin and watery to get you to the hospital. But then on the other side, if you do take aspirin, or if you're on any type of blood thinners, if you get a cut, now it's a life-threatening situation because you do not have any fibrinogen. You don't have any clotting factors. That thing is, even a little cut will bleed and bleed and bleed and bleed and bleed. It's a big problem. So, first step there is the vascular spasm, this recoil. Okay. Second one there, okay, we've got coagulation. Okay, and this happens after the platelets have plugged. Their job, those little platelets, only around for a week. That's how old they are. They just start jumping on the cut. They start plugging it. Okay, it's called your platelet plug. And then you've got this coagulation, and this is where the fibrinogen comes in. And now you've just got this mishmash of everyone jumping on the party there to try and create a plug in the hole in the artery. Okay, and here's another shot of it right here. Y'all can have a look at this. 1, 2, 3, and 4. Okay, so there's a break in the vessel wall. Okay, and then we've got some leakage here. All right, things start getting out, and then what we've got is this coagulation here, this conglomeration. Everyone is coming in here, and the platelet plugs there, and now we have a scab of some kind, a healing process there, so the blood isn't escaping. And the blood is escaping is important. We don't want that to happen, but we also don't want anything getting in. Okay. Good shot here of fibrinogen. Okay, blood clot, clotting cascade. The injury produces what we call PTA. You don't have to know that one there. Okay, but the PTA activates thrombin, and thrombin activates fibrinogen. That's what I'm interested in right there. Okay, you see these fibrous fibers there. They're sticky, and they're just making a plug. Okay, and you guys can refer to figure 1511. Okay, anticoagulants. There are some natural ones there that prevent clot formation. Okay, aspirin is one of them. We've got fibrinolysis. Okay, just the whole idea of a clot breakdown. Plasminogen activates the plasmin. Okay, and you'll see here we can get things moving. So after the clot has done its job, it needs to be dissolved. How is this done? There you go. Have a look at that one right there, okay? Drugs that affect clotting, okay? Anticoagulants. Heparin, okay? Coumadin. It's actually rat poison. It is. Have a look at it. And these guys here, if you're on heparin, if you're on Coumadin, these are the medical terms for these. These are blood thinners. And a little cut can be life-threatening. Absolutely. Okay. Elderly people there, what will happen is, you know what I mean, with a weaker heart, they'll be on Coumadin or heparin, you know, blood thinner there to keep the blood watery and easy to pump there for the heart. But what you'll see there when you go into their homes, and I noticed this there with my gram before she passes, that she was on Coumadin, and she was 98. Jeez, I hope I make it that far, you know. And you get bruising because your hands are, you know, interacting with the external world, right? So they're the ones that are going to get bumped and bruised and all this kind of stuff. And normally, I just hit my hand against the table, nothing's going to happen. But if I was on heparin or Coumadin, tiny little bumps like that, you'll bust open the little blood vessels in there, and you'll get bruising all over the place. Bruising happens all the time with people who are on these blood thinners. Now we're into the last part here. We're going to talk about blood types. Okay? And we're going to go back a bit, and I'm going to throw some words at you here. An antigen is any molecule that can trigger an immune response. Okay? An antibody, part of the immune system, okay? They each have one specific target antigen. So antibodies are looking for antigens. And these antigens are those little proteins that stick out of the cell surface. Sorry, I guess you guys can't even see me here. Okay? So these antigens, like, let's say a cell, a phagocytic cell, chomp chomp, it eats a diseased pathogen or something like this, right? And then maybe this cell is infected. But what it does is, and I have the video there, and I'll show you which one it is, it'll chomp, and it will degrade whatever's inside, but then it will take whatever's left of whatever it just ate, and it'll stick it out onto the membrane. Stick it out of the membrane. So now that's its way of telling the body what it just ate. And now it's got these little glycoproteins on the cell surface, and the antibodies can sniff it and have a look and see if this is life-threatening or not. So to go over this, antigens are any molecule that can trigger an immune response with those glycoproteins. An antibody is floating around looking for that antigen. And these guys, and antibodies are only looking for one antigen. Okay? And if it comes into contact with this antigen, it will trigger an immune response and attack. And we're going to talk about now the whole idea of what happens when you put somebody else's blood that is not compatible with your blood. That's a heck of a mess. And odds are you're not going to make it. It's a bad one. And what happens here is if you put somebody else's blood into yours that yours isn't going to react well to, your blood is going to attack this blood. And how does it attack it? Agglutination. And basically, when your body's defenses will attack this foreign blood, what happens is it agglutinizes. Agglutination, it just clumps. And now you've got these dead clumps in your blood vessels. And it's really bad. So we'll get into more of this. The presence or absence of these agglutinogens, okay, all details what is going to happen in the blood for your groups here. So let's have a look. And I've got a couple different ways here of how we're going to do this here. There are the 4 types of blood that we're going to talk about. Okay, there's type A, type B, type AB, and type O. So you'll see here, I've just written this there. This slide really isn't that helpful. It'll become helpful after we look at this slide, but I want to show you guys here that the blood types are named because of their antigen. Those proteins, okay? So type A has A antigen sticking out of it. Type B has B antigen sticking out of it. Type AB has both A and B antigens sticking out of it. And type O has no antigens sticking out of it. All right? Now, let's go back. And you see right here, I'll show you, this is type A. Okay? And so type A blood has antigen A sticking out of it, these little glycoproteins. B has B antigen sticking out of it. Type AB has A and B antigen sticking out of it. And type O doesn't have any. Okay? Maybe you guys already know something special about O. But we'll get there. Now, in order to continue, I need to remind you that there are, what is this, slide 38? Sorry, this is important. Yeah, right here. Remember this one. So, these are my RBCs down here. This is my plasma. And now, my antibodies are floating in my plasma. Now, you remember, your blood is all mixed together. We've separated it here into 3 parts, all right? But when you give a blood transfusion, you're not giving the person's all the blood. They centrifuge it down. So you're not getting the plasma. You're only getting the RBCs, all right? So you're not getting, what was that, 38? Aha. So you see here, these are your RBCs, the 45%. Think of this as your plasma. All right? So these guys, the antibodies, are floating around in the plasma. So type A has A antigen, but it has anti-B antibody. So these guys here are not looking for these ones. These guys here are looking for these ones. So if you put a B-type blood into an A-type person, these antibodies are going to just hook right onto that faster than anything, and this blood is going to turn into mashed potatoes right in your arteries. Okay? That's how this thing works. All right? So type A, you have A antigen looking for B, okay, anti-B antibodies. Type B, you have B antigens, but you're looking for A, anti-A antibodies. Okay? So these guys here are looking for these antigens. All right? You see here we've got type A and B. There are no antibodies. There are none. Because if there were, if this blood type had either or A or B floating around, it would just tackle its own blood. So this blood here doesn't have any antibodies in it. And you'll see O has no antigens, but it has both antibodies. So you see, you think about it, if you're going to get a blood transfusion, they separate the blood from the plasma. So the blood, this is what you get. You only get the RBC. You don't get any of this plasma. So, but it's still important to know what kind of blood you're getting. And this slide right here, this is just an easy one there that you guys can copy and paste and type A, B, C, or A, B, and O here. But please use these 2 slides together because I think that they work pretty well together as far as understanding what's happening here. Okay? And this slide here, you have a look. Please note that we only donate blood. We do not donate plasma. The plasma is kept back because plasma is where all the antibodies are. So, you have a look here. This is a slide there that details basically the same previous slides, okay? So have a look at this one too, and it's just in chart form. Type A has A antigen, and it has anti-B antibody, okay? Type B has B antigen and anti-A antibody. AB has A and B antigen, but no antibody. And O has no antigen, and it has both antibodies. So you see here, who can give them blood? Okay, you'll see here that O can go to anybody. O can go to anybody because remember, it's not the plasma, it's only the blood. So if O is going to go to anybody, see there's no antigens on here. So cancel all these antibodies because they're not going to the patient. Okay? Only this is going to be going to the patient. And if I put RBCs with no antigens on it into here, it's going to be perfectly fine. If I put this into here, it's got no antigens, it'll be perfectly fine. Okay? So O can go to anybody. It's the universal donor. Okay? There's a good little video right here. Come on, video.
Nicorette Quick Miss gets to work on your cravings in just 60 seconds.
Thank you. Thank you for that. It's great.
A lot of people don't know this, but the best way to make money with Amazon in 2021 is not by selling physical products.
I hate commercials.
Blood transfusions are an important, common medical procedure. So important, in fact, that we have whole blood drives in order to get...
This video here, it's about 10 minutes long. It's really, really good. If I didn't make any sense to you, have a look at this video. It'll be perfect sense afterwards, okay? This I don't know who this guy is, but he's really good. And he's got some good animation there. So have a look at this video there when you guys get a chance. And yeah, that's how that one goes. Just making sure it works there. The whole idea of antigen-antibody interaction, okay, the blood will clump, okay? It just, those antibodies, as soon as they meet that specific antigen, and it's 1-to-1, right? I'm only looking for one type of antigen. As soon as it sees it, it clumps it, brings it down. It takes it out of the game. That's what immunity is, okay? Examples of a mismatched transfusion: type A recipient, okay, has A antigens, okay, on the RBC, and anti-B antibodies in the plasma. Type B donor has B antigens on the RBC. If we mix this up, the results, the anti-B antibodies of the recipient attack the B antigens, and it's a horrible situation. And you think back that they must have been doing blood transfusions since the Middle Ages, before they actually knew what they were doing. And could you imagine taking the blood out of somebody and putting it into someone else and not knowing and just seeing what that person is going to go through and die a horrible death? Oof. There's your type O, the universal blood donor. You guys can have a look at that there. Type AB is what we call the universal recipient. Okay? Type AB, if you'll notice, type AB does not have any antibodies. Okay? So, this guy can come here. This one can come here. They can all come here. Okay? What else we got? Universal recipient. This is what I wanted to show you guys here. Now, the Rh factor. This is a hereditary thing, okay? People there with Rh factor, okay, they're Rh positive. Those without Rh factor are Rh negative. Rh negative people initially have no anti-Rh antibodies in their blood, but develop them after exposure. Okay, let's go through this again. So Rh negative people, they have no anti-Rh antibodies floating in their blood. Okay? But they will develop antibodies after exposure. Very important. And what happens is, you'll see there that during the first pregnancy, okay, maybe mom is Rh negative. Everything's fine. Mom's had a great life. She's, no medical complications at all. She's healthy as a horse. You know what I mean? No problem. Mom gets pregnant. Baby is Rh positive. Okay, no problem. All right? Baby is Rh positive. Mom is Rh negative. First pregnancy, no problem. Baby will come out fat and happy and healthy and crying and all that. But mom has now been exposed to Rh positive. No problem. except for the second child. And you see, during this process, okay, baby is Rh positive, okay, mom is Rh negative. The process there, gestation, the baby's growing, development, everything is fine. But in the meantime, mom is developing an immunity, antibodies to Rh positive. Everything's fine though, baby's born, but now mom has antibodies for Rh positive now floating through her. Mom's second pregnancy, if baby is Rh positive, now you've got trouble. And mom's antibodies will attack the fetal RBCs. Okay? So it's very, very serious, and it's taken very serious. Okay? Because we don't want that to ever happen. So you guys can have a read of Rh factor there. We've got this one here, Erythroblastosis Fetalis. This is the same thing of what we just went on right here. And you guys can have a read of that. So there's your blood in a nutshell. It was a long day, and you know what I mean? What we can do is all we can do, right? But that's all I've got there for today. And I hope you, oh my goodness, you guys are still here. So what I'm going to do is I'm going to stop recording.